Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul Nazmi bin Muhammad. My matrix number is AA191588. So today I'm going to talk about Lab 2, which is Introduction to Programmable Logic Controller. So I will be doing the Lab Activity 1 and Lab Activity 2A. So firstly, we need to develop the ladder diagram as in figure 1, which is in the lab sheet in the Logosoft Comfort software. Okay, so firstly we drag the make contact, which is the PB1, and then PB2 is the normally closed contact. Then we drag a relay coil, which is IR1 in the lab sheet. For the IR1 on the second rung, we need to drag the make contact. For the last rung, which is the relay, we also need to drag the make contact, and then we drag the relay coil, which is the fan, the output. So then we connect the wires, the fan. The fan is actually Q3, so we need to double click and then we select Q3. After we develop the diagram, here's how it looks like. Okay, so here is the result for the lab activity 1. Okay, so basically when we push the first PB, which is the PB1, the fan will start to run immediately. Then when we push the second push button, the fan will immediately stop. So PB1 acts as the turn on switch and PB2 is the turn off switch. So I think that is all for lab activity 1. Okay, so for the next one is lab activity 2, which is timer. So task 2A, develop the ladder diagram in figure 2A in Logosoft Comfort software. Set the on delay timer to 5 seconds and off delay to 10 seconds. Transfer the program to PLC and run the program. Then screenshot the completed ladder diagram. Firstly, we need to develop the ladder diagram. So based on figure 2A, firstly we need to drag to make contact, so it acts as PB1. Then we scroll down and drag on delay beside I1, which is the make contact, and then drag the off delay below the on delay timer. Okay, next we drag the break contact. So break contact, we double click and we select the timer on. We scroll down and we search for timer on. Then we drag the make contact, then we scroll down and we get the off delay contact. Then we drag a relay coil. So in the lab sheet, it is for lab and fan. So Q1 is for lab and Q2 is for fan. So then we just connect the wires. After we connect the wires, here's how the circuit looks like after we connect all the wires. This is a screenshot of the circuit 2A. So we set the timer for delay to 5 seconds and we set timer for off delay is to 10 seconds. So this is the result for lab activity 2A, which is on delay for the normally closed contact. delay timer. So when we play this video, we press push button 1, we set the timer to 5, then the lamp will immediately turn off. Okay, so for lab activity 2A, so you can see the fan is not turned on. So when we press push button 1, it immediately turns on. So for this one, when we press the push button 1, after we set the timer for 10 seconds, the fan will turn off after 10 seconds, as you can see here. So I think that is all for lab activity 2A.
Hi, Simple. So for me, I will cover the rest of the lab activity, which is lab activity 2B and also lab activity 3. So in lab activity 2B, it asks to develop the ladder diagram as in the figure to be shown below in the Go software. Then we need to set the timer to 5 seconds, and after that we just transfer the program to PLC and simply run the program. So in this figure shown here, it uses two push buttons, which is our input, lamp, fan, and a buzzer that act as our output and a on delay timer. So how it works? So as we can see here on the first round, our push button 1 is connected in parallel with push button 2 and go to the lamp. So technically, when we press the push button 1 or push button 2 or both, the lamp will turn on immediately. In the meantime, the lamp coil will energize and the timer will automatically start counting. As stated above, we set the timer to 5 seconds. It means that after 5 seconds, the timer contact from normally open will become normally closed and somehow will turn on the buzzer and also the buzzer and the fan simultaneously. So now let's see the demonstration video that we have done on the lab session before.
On. So on. Second push button. 5 seconds.
Okay, so let's continue with the last lab activity, which is lab activity 3. On this lab activity, it uses 3 push buttons as our input and a buzzer as our output. As you can see in the figure shown here, in the first round, push button 1 is connected to the reset pin on counter. It means that the push button 1 here is act as a reset button. On the second round, push button 2 is connected with the CNT pin on counter, which means that it acts as a counter where we need to press and release the push button repeatedly so that the counter starts counting. Next, on the third round, push button 3 is connected to the DIR pin, where it used to turn off the circuit, or it can be a direct switch to turn on the circuit immediately without using counter function. And lastly, on the last round, it has counter contact that goes to our output, which is buzzer. So how it works? So basically, the main working mechanism of the circuit is to press and release the push button 2 according to the counter value that have been set. The buzzer will automatically on once the counting process is fulfilled and the counter contact turn close and let the current flow through it. So let's take a look at our demonstration video that we have been doing last week.
On. Two. Off. So off and two. They already reset. So the first observation, state the IP address, subnet mask, and gateway for your PLC unit. So the answer is IP address is 192.168.000.003. Subnet mask is 255.255.0. Gateway is 192.168.0. Number 2. State the actual numbers of input and output available at the Siemens logo PLC base unit. The inputs are push button 1, push button 2, push button 3, and counter. The outputs are lamp, buzzer, and fan. Observation 3. State the address of the input switches. The address of the input switches are as follows: PB1, PB2, PB3, and counter. Observation 4. State the address of the output lamp, buzzer, and fan. The address of the output lamp, buzzer, and fan are as follows: lamp is Q1, buzzer is Q2, fan is Q3. For question number 3, explain what happens when the outputs are connected in parallel. So the answer is the outputs can only be connected in parallel if there are two outputs. If there is less than two outputs, it cannot be connected in parallel. For question 4, discuss the importance of PLC in industrial application. The PLC, Programmable Logic Controller, is a mechanism that automates the operation of machinery and systems. It includes three basic features: input, method, and output, all of which must work together well and harmoniously. In order to achieve desired result or output, the input or data must be combined with the appropriate operation or procedure. It's a long and difficult process to automate all of the machines.